start. Okay, today we're gonna talk about these two concepts in programming, list and loops. This is important because this is the probably most fundamental way for you to create a lot of data programmatically. So before we go on, let's briefly recap what we did last time. So last time you guys were introduced to the concepts of variable, data or value, and the data type of the value. So in Python we can declare a variable that has a name. Okay, the variable can contain data, and the data belongs to a particular data type. So in this example, a variable, as I told you last time, think of a variable as a little container that contain value, and it actually takes up memory in your computer. That's why think of it as a container is kind of a more or less the right image to think about. Okay, the container has a name. Okay, and the name of the container does not change. It's called my text, but the value stored inside can be changed. So the first line of the code will give us a variable or a container with the value, the piece of text hello. Now this is the data, or the value stored inside the variable, and the data or the value belongs to a particular data type. In this case, it's a text, and in programming language, text is called a string. Okay, and then we have a number. All right, this is a decimal number, and the data types represent decimal number in Python. And in many other programming languages as well, it's called float. All right, so we can change the value of. So once the variable has come into existence since our program started running, the value can be changed, but the variable itself, doesn't change. The box is still sitting there waiting for the data to be manipulated. Okay. And then we also set up a simple, I show you how to do a Python script workflow in Grasshopper, where we set up a Python script with custom input and output, where the input and the output name can be changed, and the input and output will be treated as Python variables when we write the scripts for these components. The input has a data type, right? So whenever you do the input, right-click on the input and choose the type hint, because type hint is important. Like the script relies on the type hints to do the data conversion and autocomplete when you type the code. Okay, this is what the code looks like last time. Last time we were introduced to the Rhino.geometry library inside the Rhino common library, and that library gives us access to all of the geometric data. In this example, we deal with this data type called pawn 3D that represents a pawn in 3D space. Okay, so because A and B are pawn 3D, it has the .x and .y properties. Okay, so its data type comes. So if you have a piece of data or a variable A that belongs to a data type, then it will has all of the property of that data type. Okay, so A is a pawn 3D, and any variable that belongs to the data type pawn 3D has the .x and .y and .z. And why we know? How do we know about these properties? Because we look up at the documentation. Okay, but of course, in this common case, you will kind of remember by heart anyway. Right? A pawn always must have .x, .y, and .z. Python is a case-sensitive programming language, so it's always distinguished between lowercase and uppercase. So by naming convention, a variable name, for example, this is a temporary variable that we declare inside the body of our Python program. The variable names always start with lowercase, okay? But whenever you have a new English word, you start with uppercase again. Of course, there are exceptions, but in general, we use this so-called mixed casing. Mixed casing means that we start with lowercase and then we have an uppercase whenever we have a new word. But the property, so the variable, so this variable, this is a variable, input variable. So it should be lowercase, but I name here is uppercase because usually if a variable represents a point, then because in mathematics we tend to use uppercase letter to represent points. So here I break the rule, I break my conventions, and I use an uppercase. Okay, this is not a rule; this is a convention, which means if you violate it, the program still run. Okay, the difference between syntax, rule, and convention. Okay, so the naming here is a naming convention, but not a naming requirement or a naming rule. But of course, we encourage everybody to follow the convention so that when other people look at your code, they have an easier time to figure out what is going on. Okay, so speaking of naming convention, so we're still carrying on with the naming convention thing. So property. So whenever you have a variable and then you dot and then the dot is where you use the dot to access the property of that variables, and the properties always has the uppercase naming conventions. Okay. All right. What is this function here? This is a function or a command that create upon 3D data from scratch using 3 numbers. Okay. The command in the Rhino common library. So this one came from the Rhino common library. Right, it's always start with uppercase. However, the command that built into the Python programming languages, as you will see later on, like the print command, for example, usually start with lowercase. So there's a bit of inconsistent conventions because Python somehow has not as strict as convention of the C# language. And the Rhino.geometry and other library inside the Rhino common were written in C#. That's why they use the C# naming conventions. Okay, so okay. And whenever you have a command or a function, your code editor will always display it in blue. Okay, and the functions or command describe an actions. Okay, a variable store data, so it's like a noun. Okay, and this is an action, so it's like a verb. Okay, so when you execute an actions, you always have to open the bracket and give the input parameter to the actions. Some action does not require any input, but even in that case, you still have to open the bracket. It's just that the brackets are empty. Okay, when you use a variable or create a variable, you will never have brackets follow the variable. Okay, but the functions, whenever you use it, it's always have the bracket. Okay, so even without understanding the name, even if I give this function a very weird name like XYZ, but by just looking at the bracket, you can distinguish between a variable and a command. Okay, the command is actually not a real terminology, and the correct word is a functions or method, but we haven't done that, so I use the word command, which is probably easier to understand in a normal context. Okay. All right. Here is a command, but these commands belong to the data type pon3d. So that's why we have a variable of type pon3d, and when we invoke the command, and the command take in the input, which is another pon3d. Okay, these commands come from the library. Okay, this command is defined for the data type pon3d. That's why in order to use this command, you must have an object or a variable of pon3d first. Okay. Okay, why this command is a so-called constructor command. Okay, so you use it without a variable. You just invoke it from the name of the library. Okay. All right, so that's what we did last time. And then you did an assignment based on that, so I hope all of this basic routine is clear. Again, I know a few of probably 2 or 3 of you are already familiar with this, because you've been doing Python for years or other programming language. So what I've been talking here is very kindergarten level to you. So, but please bear with me. We have to get through all of the basics first, and we have to the assumption of this course is that none of you have programming, so everything has to be explained carefully from scratch. Okay, all right. Now, here you know how to do a single variable, right? So let's say that if you want, and then, okay, last time we also create a point. Okay, this is how we create a single variable that represents a point, right? And if you want to do 100 points, obviously you can do 100 lines of code where it's you create a brand new variable, but normally nobody would do that manually, right? Usually there is a rule that generates these points. Okay, but even before we talk about generate response, let's talk about what is a convenient way to store multiple items or multiple points, but like items in general, in one single entity, and that is called list. Okay, now if you are a Grasshopper user, you know what a list is, right? It's just a collection of multiple items, but that list is being treated as one single item and can be stored in one single variable. Okay, so that's why it's convenient. Let's see how it works in Python. Okay, so yeah, the list in Python is of course it's different from the list in Grasshopper. There's some similarity, but underneath it's different. But you will see the similarity and the difference in a moment. So what is a list? A list allows to store multiple items in a sequential manner. Okay, and the whole list itself can be treated as one big item. Okay, and can be stored in one variable, or stored in one variable so that we have a name to refer to it, right? So when you store data in a variable, the variable just not only contains data, but it gives us a way to refer to that data because it has a name attached to it, right? So when I have number 2 and I store it in a variable called my floor area, then of course later on I can get that number 2 by saying out the variable name, my floor area. Okay, so all right, so this is like a Python code. This part is the command. So as last time, as I explained, if you have a hashtag symbol, then anything behind, that's anything that comes after the hashtag symbol on the same line will be interpreted as just command, just like a little piece of annotation text that Python will ignore when it runs the program. So this is just for human, just like piece of annotation, so like human programmers can understand what's going on. Okay. Okay, so here we create a variable called heroes. Okay, and so this is just a variable, it doesn't have anything yet. And then on the right hand side we actually create data, and the data is a list that store a collection of strings or text. Okay, now here I manually specify the value of text. So this the value of the list. Okay, the list has 3 elements or 3 entries. Each of the elements themselves are a piece of text that represent the hero names. Okay, so and they are separated by comma, and they are enclosed in square brackets. Okay, so this is the data of the list. Okay, and this is one big list, and I store the entire list into this variable called heroes. Okay, and now if I say print heroes, then the contents or the value inside the variable heroes will be displayed. Okay, so I can try this quickly. I don't think anything. So a Python component. Okay, zoom it in. You don't have to try this one. I think it's very unsurprising, so you can just watch me do it live. Okay. So print heroes. If I run this, then at the bottom it will display the content of the list: Batman, Wolverine, and Superman. All right. Okay, so that kind of. All right, so like carrying on. So in the same program, after that, we already have a list. Okay, how do we retrieve one particular item in the list? Okay, so when you store items in the list, each of them have an index number. So this one has an index number 0, 1, and 2. Okay, and then so on. So if you want to retrieve the 0th element, okay, so in order to retrieve, you say heroes. So you write out a list name, you open the square bracket and give it an integer. Okay, and then this whole part will be executed and basically will give you the first element, the 0th element. Okay, and which is a piece of text, right? The text Batman, and we store the text in the variable first hero. Okay, and if you print our first hero, you will see Batman. Okay, so this part retrieves the value. Okay, but we store the value in a new variable. Okay, again, distinguish between value data or data and a variable. Okay. Now, if we say, if we give it a negative index, then it counts backward. Okay, so index -1 will basically Superman. Okay, and -2 will be Wolverine. Okay, so Python allow you to retrieve an element using negative index. So the last index is always -1. Okay, so it's kind of convenient. Otherwise, you will have to kind of memorize how many elements this guy have, and then the last element will be, you know, the number of element -1. Okay, but if you want it, but with this negative, you just say -1. You don't have to even know how many members, how many elements are there in the list to begin with. Okay, and then retrieve a sublist. Okay, so a sublist is similar to the sublist command in Python. So you open a bracket, you say 0, which is the starting index, and this is the ending index. Okay, so you start from index 0, and then you take the sublist up until the index just before this one. So it takes 0, 1, and stop at 1. It never reached index 2. Okay, so if you take a sublist with 2 parameters, 0 and 2, it will give you a smaller list that contains Batman and Wolverines only. It might be strange why it kind of stopped before just number 2, but you know, in programming language, usually the upper limit is exclusive, so it's always stopped just 1 unit before that. Okay, it's a maybe semi-odd convention, but yeah, it's just the way it is in not just Python but many other programming languages. Okay, now the kind of command that you can do with list. Okay, I call it list functions, but again, we think of it as commands now. They kind of synonym for now. So let's say that we have a list that we declared previously. I show you how to retrieve an element from a list, right? Which is just like open the square bracket. This is like retrieve an element from a list. Okay, but you can also change the value of an existing element. Okay, so here I accessed the first element, and then I reassign the value to a new text called Thor. Okay, so after this line, if I print out the value of heroes, then my list heroes will be Thor, Wolverine, and Superman. Okay, nothing surprising. Okay, well, I'm not going to try it live because I think it's simple enough to understand. Adding or remove element to a list. Okay, so if you have a list heroes and you say .append, okay, so this is a command that was defined for anything that has the data type list. Okay, so you need a list first, and then you say dot, okay, and then append. Okay, and then we give it a new item, and this item will be append to the end of the list. Okay, so at this point, if I have a print command here, if I say print heroes and I execute the program, then the print heroes will give me Thor, Wolverine, Superman, and Captain America at the end. Okay, so append means add a new element at the end. What if you want to add multiple items? So then you use extend. So heroes.extend, and then you open the bracket is a command. So you open a bracket, and then the parameter to this bracket is another list. Okay, so that's why inside the round bracket I have a square bracket. So this list will basically be add to the end. Okay, so append take in one single item, but extend take in a list and will attach or append this entire list to the end. Okay, so after I run this command, my list will be Thor, Wolverine, Superman, Captain America, and then Ant-Man, and then Robin. Okay, so far so good. Okay, so append and extend always put element at the end of the list. If you want to insert an element at like somewhere in the middle of the list at a specific positions, then you can use insert. Okay, so heroes.insert, and this insert command takes 2 parameters. The first is an integer that tells you know which position of the list that you want to insert into. Okay, so insert 1, which means that it will be right here. Okay, and then the item will be Hawk. Okay, so after this line finish, Hawk will be insert, and Hawk will have the index 1 in the list, and everything else will be shift 1 by 1 index like behind. Okay. Now for list, append and extend is like very computationally very cheap to execute. Even if you have a list of like 1 million points, like if you represent a point cloud, you start up in a list of like 1 million points, right? Now adding a new point to the end is very easy, right? I mean computationally easy for the computer to do. But insert a point, let's say if you have 1 million points, then you want to add a new point as like position 1. what happened inside the computer is that even though when you write a code, it's just one line, but what a computer actually does is that first it has to shift all of the 9999 elements backward by 1 unit to leave space to insert that new one. And that shifting, which basically equal to copying, by the way, is expensive, computationally expensive if you have like million points or multiple points. And later on, it's kind of often where you write a program that will be executed like 30 times per second. Like if you write a piece of Python text that like simulate a robot running in real time, then usually that robot will, that code will need to be up to date like 30 times per second or even more. And then if every time you have to process a list of million points, and then each time you insert something, then it will computationally, you can see that like your script runs like at a much lower speed. Okay, so that's something to keep in mind. Now you're not going to experience that anytime soon because all of the example that we're gonna do is just a few hundred points, and we do it only once. Okay, so it's gonna take at most like a few milliseconds, so you won't feel the difference. But when you do million points and when you do it together with many other stuff, then every like 10 milliseconds that you save is like important. Okay. Okay, same with remove. So here we remove Superman. So it will scan the list to see if there's anything that match this item, and then it will remove everything. Okay, remove is also expensive because after you remove, you will have gap in the list, right? So behind the scene, the computer will have to ship all of elements, forward to fill in the gap. Yeah, that's the problem. List is a continuous sequence of items. If you remove one thing, everything in the sequence has to be shipped back to fill in the list. Okay, and it happens behind the scenes, so you don't see it, but it actually involves a lot of computations. Okay, other useful list functions. So count, sort, reserve. Okay, so count, sort, reserve. We're not going to use it right today, but it's good to know. Okay, but this one is important. So if you have a list and length, so length is a kind of a odd command because you should say length. Okay, it doesn't. You don't prefix it with anything. Length is a built-in Python command. Okay, so you should say length. It already being recognized. You don't need to import any library. So length, and you open a bracket and you give it a variable of type list, of data type list. Okay, and it will return a number that represent how long is the list. So length is in the length of the list, or the number of elements in the list. And of course, length only works with list. So heroes is a list, so that's why length this code will happily run and give you number 3 because you have 3 elements. If you say length and you give it a point 3D, of course it will complain because it will say that length functions expect a list variable. Yes.
For this sort function, based on what does it sort?
For number is obvious, right? For string probably is also obvious, but not everything can be sorted. So if you have a list of a point 3D, then if the Rhino common library does not define what it means for a point to be smaller than another point, then the sort function will return error, say that point 3D is not comparable, because one part of the sorting is you have to compare elements, right? But not everything is comparable. For example, what do you mean by comparing two spheres? Okay, so if you have a list of spheres and you can sort, I think you get an error message. Okay, for number and string, the comparisons has already been defined by part of the Python programming languages, at least the basic Python libraries. Okay, but anyway, if you want to sort points or whatever, then you will have to specify a way to compare between 2 points. For example, if you want to sort between the x and the y and z, we're not going to do that today. Okay, but just something to keep in mind. But we're not going to deal with that immediately. Okay, so this function is quite commonly used. Even if you're a Grasshopper user, you might know that one of the most common thing with lists is like just to query how many elements in the list, right? So that's the equivalent in Python. Okay, so that is a list of text. Of course, you can store a list of number as well. Okay, but you can use list to store geometry object. Okay, so list and Rhino geometry. So let's say that here. So one way to create a list is just to explicitly declare every element in the list, okay? And then you further remove or add things in. Okay, so now in this example, I'm gonna do something slightly different. I'm gonna create an empty list, so empty square bracket, okay? And I'm gonna store Pond 3D inside, so that's why I need to import the Rhino geometry library, because I need this library to create the Pond 3D in order to append it to the list. Okay, so here I do everything in one line. Okay, so this part, g.pond 3D, create a pond. You know this part, right? And then this thing runs and give me a point, and then I will send it to the function command append. So, okay, this guy is a function name, so it should be blue. Hang on. Okay, so blue. Okay, so point, which is the list, append, okay, and give it a point. But here I don't have a point, so I create the point. Okay, so this is actually usually two separate lines. The first line, create a point, you store it in a temporary variable, and then you send that variable as an input to the function append. But here I do everything in one line. Okay, because again, this is a command, but at the end of the day, when it runs, it will be evaluated to a single piece of data. Okay. And here we don't store that data anywhere. We send that data or that value directly to the command append. Okay, so if we run, okay, this is something that we should try live. Okay, so this is the list of points, and then we're going to output it into the output port O points. Okay, so O point is the name of the output port, and usually for output port, I prefix it with the word O to know that this is an output. Okay, so let's copy this code. Go to Rhino. Okay, I'm gonna create a new Python component. All right, I changed the output name to O points. Okay, I don't need the input really, but so I just leave it there. And if I run this code, okay, I should see a bunch of points being output on the screen. There. Okay. Yes?
Sorry, why are you updating the variable of all points? Those points is you changing points.
Yeah, so point is my internal variable. It's only live inside the Python. Okay? If I don't send this out.
Oh, that's your output. Okay.
Yeah. So anything that has the word O, according to my convention, will give you a hint that this is an output.
Okay.
Yeah. Okay, why don't you, I give you 1 extra minute, and then why don't you create a simple list of numbers and then send it out to an output called O numbers, okay? Now the numbers will not be visible on the 3D viewport, but it's only visible in the Grasshopper, okay? Let's try that. Okay. All right, I think we should carry on. All right, so now we know how to like manually do a list in like so append single item, but so far every element has to be specified manually, right? So if you have 100 points, you kind of have to specify them, have to define them manually. Okay, so that's why we go into the next topic that is different from list but related. They are often used together. So list is a data structure, a concept to store multiple items. Now loops is kind of programming or an execution pattern. It's not a single command, but it's just a programming syntax that controls how the program is executed. So far, when you write a program, the program will execute from top to bottom, right? And if you have an if statement, like as we did last time, okay, some of the lines of the code will be skipped, okay? Now, the next kind of programming structure or syntax is that we're going to learn now is a loop or, a for loop. There's many versions of loop, but the most common one, or the first one that we're going to learn is for loop. Okay, so the syntax look like this. Okay, so this is the beginning of our program. We say for I int and then a list of elements. Okay, for and int are keywords or reserved words, so that's why they will be displayed in like light blue color or like kind of cyan blue color. Keywords are a kind of special word that reserved in the program, so you shouldn't use it to name a variable or something like that. Okay, it's just like the keyword if that we done last time. Okay, it's a special command word that Python will use that to like interpret the execution of the program. Okay, so for I, now I is just a variable name. Okay, so that's why it's black, and I it's just a name that we chose. Here I just called it I. Okay, and this is a list. Okay, so we write a line followed by a colon. So I'm missing a colon here. Okay, so this file will be update. So I make various adjustment on the PowerPoint file. So at the end of the day, you should re-download it from Google Drive to make sure that you have the most up-to-date version. Okay, so we had colon, just okay, and then in the next lines we indent, and then we're gonna write a mini program. Last time we did an if statement, right? We if and then a condition and then colon and then the body of the if statement. Now this is a loop, so this is the header, the first line of the loop. We do colon and then we have a mini program that is written just below the for loop, and the program has to be indented relative to the first line of the for loop. Okay. Now here we have a mini program that does a very simple thing. Just print out the value of the variable I. Okay. Now at this point it's not clear what is the value of I, right? I is a variable, but the way we declare is kind of special. We declare it like within the keyword for and in. Okay. So what is the value of I when this piece of code runs? So what it does is that so when you run this program, print I will execute for as many times as there are elements in this list. Okay, and each time it's execute, I will take the value of each element in the list. Okay, so this code is equivalent to say print 0, print 1, print 2, print 3, and print 4. Okay, so this mini program here, okay, this mini program has only one line. Okay, it will be executed 5 times, and each time I will take the value of each element in the list that you give it. Okay, so let's try this first. Copy. Okay, I'm gonna use the same component, so I'm gonna actually I will use another component. Python. Okay, so I should see 5 number being printed out. Okay, 0, 1, 2, 3. Okay. Now, of course, this program doesn't like output anything onto Grasshopper, right? It just displays the value inside the output panel. Okay, it doesn't produce any geometry or any like useful thing yet. Okay. So now this is a list, right? I declare the list right in here, but if I want, this list can come from like somewhere else. For example, imagine I already have this list called inter or just elements. Okay. Okay. Imagine that this list already exists before. Okay, in a variable called elements, and I can say for I in elements. All right. So normally this is how you use the for loop. You don't explicitly declare the list right in the same line. You got a list elsewhere before. Okay. Okay, and this one will give you pretty much the same result. Okay. All right, the next step, you don't have to follow me, just what? Don't need to follow. Okay, so in many cases, we want to travel a list that has basically the value that's going from 0 to like let's say 100 or something. A list that like just a direct sequence of number increased by 1. Okay, so it's kind of convenient to have a way to generate this list automatically, right? So if you want to have a list of 100, like you don't want, of course you don't want to like say 5, 6 up until 100, right? So there is a built-in command called range. Okay, this is a built-in command. So this guy, okay, it takes in 2 parameters, the starting integer and the ending. Okay, you don't have to follow this step, just what? Okay, this command, when it's run, it will give you a list that go from 0 to 99. Again, it's always stop just 1 before the upper limit. Okay, now if I print out elements, okay, let me remove the for loop, we don't need it. So if I print out this one, I will see a list that go from 0 to 99. All right, we're gonna use this quite often. Okay, so now I can do everything in one line. So again, you don't have to try this for I int. Now this time I would normally what goes in here is a list, right? But here I use a range to generate a list. For I in range 0 to 9, actually to 10, so it will stop at 9. Print out I. Okay, and this should give you 0. Okay, so remember this is a command, but at the end of the day it is a list. All right, and the for loop. The job of the for loop is to visit each element of a list. Okay, and each time it visits, it executes something. It executes a mini program, and inside the body of the mini program, you can use that particular value that we are currently visiting. Okay, and the value is stored in the variable called I. Okay, so the value of I actually changes each time. All right. Now this program can be as complicated as you want. Here I just say print I, but of course I can also print I plus 2. Okay, and then just for visualization, I print out just a separator line, so just a piece of separator. All right, when I run this thing, so the first time the loop execute, I got 0 and 2, and then the separator. Okay, and then the second time the loop execute, I have 1, 3, and then the separator. Okay, so the program can be as complicated as you want. Okay. Everybody got this part? Okay. All right. Now let's use. Now we use the for loop to kind of generate number, right? Now let's use the for loop to create geometry. Okay. So let's say that you want in this simple example, we're gonna create a list of points where the x coordinate is basically go from 0, 1, 2, 3 up to like 49, and the y and the z coordinate we just put them as 0 or like some fixed number. Okay, so we have a for loop with the variable, the counter variable called I, okay, and this will visit its element in list come from 0 to 49. Okay, each time it runs, we're gonna read out the value of I, okay, and we use it to construct a pawn 3D, okay. I store the pawn 3D in a temporary variable called myPoint, okay. So this variable declarations live inside the body of the for loop, as you see, all right, and then I append it to a list called points, okay, but this list came from, we haven't defined this list yet, right? So before the loops run, we have to create an empty list first. And then we use the for loop to generate points individually. And then we populate that point into the list points, okay? Of course, don't forget to import. And then, okay, so after this for loop will be executed 50 times, okay? So after this for loop finish, so like the code just go in here and it will run like it's coming in a loop for 50 times, and then after it finishes, it will go to the next line of the code, and the next line of the code will basically just output points into the output port. Okay, so let's try this program. So let's create a new Python component with the output called oPoint. Okay, so just to demonstrate, you don't have to follow this step, so just think and answer the question. So here I have indentation, which means that these two lines of code belong to the for loop, right? So these two lines of code will be executed sequentially 50 times. What if I forget to indent? Okay, if I don't indent, then obviously this part will be outside the for loop. So only this line will be executed 50 times. Then after those 50 times have like fully finished, then this line will execute. So what happened in this case?
Only the last one.
Yeah, okay. So what happened is that the first time it execute, it will have a variable. So the first iteration, okay, so the first time this thing execute, you have a new variable comes into the system. It has this value. And then from the second time, the value will be overridden with a new value. And then when it stop at the last one, then only the last value will be appended to the point. So if you execute this one, yeah, you will only see the last one. Okay, these 4 points came from the previous components, actually. So I should turn off this component so you don't see. All right. Okay. Right. Okay, so remember, when you have a variable that Python has never seen before, like this, then Python will create a brand new variable for you and put in the value. So during the first iteration, when I equal to 0, that is the first time that my pawn came into existence. But from the second time onward, it will generate a new data, but it will start in the same variable. Okay. But here the append, what append does is that it extracts the current value stored inside and then append it to the list. Okay. So that's why even though we call it my pawn 50 times, but each time my pawns will store a different data inside it. All right. All right. Of course, here we fix this list, go from 0 to 50, but I can make this a custom input. All right. So you can follow this one. It's particularly simple, so you don't have to. But instead of having 50, let's make this an input parameter. So I can, of course, make this call this I point count. Okay, so this is an input, so I tend to name some according to my naming conventions. This is not standard Python naming convention by any means. This is my own convention. So all of the input I prefix with letter I. This one is obviously an integer. Okay, and then here I have it I point count. Okay, and then I should give it a number, maybe a slider. No, 20. Okay. Oh, this is the wrong. Sorry, this is the wrong component. I should do this one. Wait, what? I count here. I point count. Integer. Okay, and if I change the number of points, the script will be re-executed. Okay. So the benefits of naming an input parameter with the letter I is that when I read a piece of code, I immediately know that this variable came from outside of the Python program. Okay. Otherwise, I will imagine that you have a large program and you see something called just point count. Okay. If I don't use that naming convention, and then you're gonna have, oh, damn it, where did I declare this point count? So you look in the previous part of the program and try to figure out where you define point count at first. And if you have a large program, it's kind of confusing, okay? But if you use this naming convention, you see the letter I, and you know that okay, it came from outside. It was not declared. It was not declared anywhere in the previous part of the program. So don't bother looking for it. Just look for it in the main grasshopper canvas instead. Where's my mouse? Oh, okay. So I encourage you to use this naming convention because as the program gets large, this extra piece of information will save you some time scratching your head trying to understand where that variable comes from. All right. Okay. So now we know how to generate geometry. Why don't we spend okay, actually, no, let's carry on. We don't need to, the next exercise will actually get this point across quite well, so we don't need to separate exercise. Okay, so we done list, we done loop, right? And in last example, we just show how to use a for loop to populate the elements inside a list, or so a list which is initially empty, or maybe it already has some data in it. Okay, but then we use a for loop to populate the element of a list, and the element is generated using certain rules. Okay, the rules here is just the x and the y just increase by 1 every time, so that's simple rules. But as you see in this exercise, this big exercise, we're gonna have some more fancy rule than just advancing the points by 1 unit each time. Okay, so this is the output of this live exercise. We're gonna create a list of points using a for loop. We're gonna put it in the list so that we can output it. Okay, but the XYZ coordinates of the for loop is controlled by a simple mathematical rule to give us this spiral shape. Okay, and then finally we're gonna draw a curve through the point. So last time we showed you how to construct a line object, a circle object, a plane object. Okay, this time we're gonna do a curve, and curve is a big topic itself in Rhino modeling, right? Even separated from programming, just like curve modeling is like a big topic. You have so many type of curve, many concepts you need to learn about curve. Here we just do a simple NURBS curve that go through all of the points that we create in the previous step. Okay, and this is called an interpolate curve. So an interpolate curve is a curve that goes through a set of predefined input points. Okay, so let's prepare a Python component without any input and an output with called O points and O curves. All right, so let's follow along. This is a live example that you can follow along. I'm gonna delete everything, do a new Python component. No input and only 2 output. Okay, so this is what a program looks like. It's very short, but the body of the for loop is more sophisticated than the one we did previously. So import. Okay, so the first library, you know what it means, right? Now the second is a Python library called math. This is where we have access to all of the basic high school math functions like absolute, then cosine and sine. We're gonna need the cosine and the sine in this program, so that's why we import the math library. Now the name of this library is short enough. That's why we don't need to give it a nickname. Okay, so in the code, whenever we want to use a function or the commands inside the math library, we just say math and then dot and then the name of the command. Okay. Now, as you see here, the naming this is a Python library. That's why it's they use lowercase naming convention. This one is a C# library. That's why it's uppercase. So yeah, there's some like confusing inconsistency in the naming conventions there. Okay, now this is now we go into the main part of the program. We have an empty. We generate or we define an empty list at first. Again, you don't have to type in yet. I just listen to like understand the code first, and then you can always type it in or copy and paste it in. All right. So our goal is to have a for loop to generate points along the circle, right? Previously, we have a for loop to generate point along the straight line because the x and the y coordinate just advanced by 1 unit. That part is easy. Now this one is slightly more sophisticated. All right, so we have a for loop that runs from 0 to 9. Okay, now each time the for loop runs, okay. So when I equal to 0, we should get this point. When I equal to 1, we should somehow compute this point. This one is I equal to 3. Okay, so how do we get, given a value of I, how do we get the x, y, z coordinate of this point? Okay, the z coordinate is going to be 0 because this is like just on the x, y plane. Okay, so the z is 0. That part is easy. What about x and y? Okay, so we can use the we just need to this angle alpha here. So alpha is going to be, we're going to define as I times 0.25 radians. Okay, so each time the loop runs, alpha will be increased by a small fixed interval of angle, right? So 0.25 radians. So in programming, the angles are usually done in radian. The cos and the sine are always like take in inputs in radians, not in degree. Okay, so that's why even though this one looks like 15 degree or like 10 degree to you, but actually we have to do it in radians, which is 0.25, not 10. Okay, 10 will be like really big because 10 radians is like really big. It's gonna be like 3 full circle almost. Okay, so we compute the angle alpha, which is just I times 0.25, and then if we know the angle, we can compute the x coordinate and the y coordinate. So the x coordinate is going to be the length of this line, which we're gonna assume to be 10. Okay, so in this example, we just assume that the radius of the circle is 10. 10 times the cosine of this angle, right? So this is just some high school math. So we say math.cos. So the cos command will take in the radians, which is just a float number, a decimal number. Okay, and the command will execute and give us the cos value. Okay, and we multiply with radius. So this is basically just high school math. And then y. Okay, so the y coordinate is gonna be the length of this line times the sine of this function. So the y coordinate is gonna be the length from here up to here, obviously. Okay, and the z is gonna be 0, so nothing fancy about the z. And then from the x, y, z, we can construct a brand new point 3D. Okay, using the x, y, z that we just previously compute, and then we append it to the list of points. Okay, so that is the entire body of the for loop. Okay, so this thing will be executed 10 times in total. These 5 lines here, and then after it finishes execution, the list points will contain 10 points. Okay, so at first empty, the for loop will execute and populate the data, and then now after the for loop finish, we can just output the data. Okay, so we can try that. Any questions? Okay, I hope it's clear. Right. Alright, so that is the first step. We just generate point along the circle, just 10 points. Now let's move to the next step. Alright, in the next step, we're gonna make two changes. First, we're gonna increase the number of points to 100, okay? And then secondly, we're gonna change the map for the z coordinate. So far the z has been put at 0, right? This is the previous step. But now we make it I equal to 0.4 unit length. So which means that every time that I advance by 1 unit, the z will be advanced by 0.4 units length. So basically you go in circle, but also the z rise linearly. So you end up with a spiral, okay? So if you run this code, you should get a spiral. I think it's more like a helix, not a spiral. So yeah, spiral is a 2D shape, but helix is like a spring shape, so that's called a helix. Okay, my Rhino just crashed, so I have to do this again. Hang on. All right. Now, so as you see, like using the index number I or the counter variable I, we can transform the value of I to the XYZ. So XYZ here clearly depend on I, right? So I dictates what is the value of alpha, and alpha dictates what is the value of X and Y. Okay. So as I change, everything changes according to the rule. What else can we do? So just for example, this one is rather than using a fixed radius of 10 for like the size of the radius of the helix, rather than using 10, why don't we make this thing also depends on I? So this number 10 here, okay, so I will make this thing called radius, okay, and just pretend it's 10 for now, and then I replace this number 10 here with radius, okay. Radius. Okay, so basically this is the same thing. I just put it in alright. But instead of using 10 as a fixed number, why don't we say 10? So it starts with 10, and then every time I increase, we will add a small number. So I times 0. Let's say just 1, okay? So the first point will basically has the radius 10, and then the next one will radius 11, and then 12. So it's basically the radius will increase as we go up, in space. If I run this, okay, you see how the radius kind of start to expand. Okay, increasing by 1 step each time looks a bit too much, so we can slightly adjust it. So 0.2 maybe is better. Okay. All right. Okay, so that is the first half of this example. Okay, so in this one, we show you, I show you how to use a for loop to generate a list, right? and then we output the list. Okay, so here even though we have only one output port, but because it's actually output the list, that's why we see a lot of data even though we have only one output port. Okay, all right, now the next step is how to use input, how to use list as an input. Okay, and then what kind of interesting stuff that we can do with that list. All right, so imagine you have a list. So this is a list of points coming out here. Okay, so this is a list of points that we generate by ourselves using Python, but you can have this point generated by other built-in Grasshopper components. Okay, it doesn't matter, but as long as you have a list, you can plug it into another Python component. So okay, let's create another Python component right here. Okay, this Python components, we're gonna write some program for it in a moment, but let's create an input. This input gonna be a list of points, so the name is gonna be I points. Okay, all right, now the type hint is gonna be point3D, obviously. So right click, type hint, point3D. Okay, but this time it will not be written as a single item. It will be written as a list. So we right click. So by default, it is an item access. So it's always like expect you to give it one item. Okay, if you give it multiple item, it will like take in one item at a time and run as many times as one. But here we take in a list. Okay, and okay, so that is the input. Now we have to give it some real data, and I will just use the list of points that we generated previously, and I plug it in here. Okay. Okay, but of course this list of points can come from somewhere else. It doesn't have to be like the points that we generate here. Okay, so now we input a list of points. So now inside the Python script, so if I have a piece of Python script here, and if I retrieve, so whenever I refer to I points, this one will be a list because we remember we read it in as a list input. Okay, so this is a list, which means that because a list you can do everything with it that you can do with a list. For example, you can query the length. Okay, if you print out a length, you should get 100 being printed out right there. Okay, because yeah, it's a list. All right. Now let's say if you forgot to set this thing to a list, okay, then this is going to be a single item, right? So what happened is that because it's a spec one single item, but you give it 100 items, then it will take in the first item, run this once, and then the whole thing will be executed 99 more time. Okay. But each time it's execute, it will be the I points here will actually be just 1 point, and then what happened is that you will get an error message. It say that let's see. Oh, it's giving me free because the points. So if I forgot to set it, okay, let me repeat it. This is a bit hard to explain because it had a side effect that I didn't expect it. So if you have a point and you say you print out a length of points, it's always give you free because internally a point use a list of free elements to store X, Y, Z. So when you say, but it should not be like, because the keyword length was meant to work with list only, but because internally a point is a list, so okay, that part is confusing. I should not. So if you forgot to put it in a list, so if you say that I point is just an item, so it will only take in the first item of the list, and then when you say length of that single point, it will just give you this number 3 here, yeah. And then and then it will be executed 100 times. So for each point, it will say number 3. Okay, but it's not a good example. So anyway, just leave it there. Okay, I put this back to list. All right, so what we can do with that, let's see. Okay, so we take in a list of points, and in this exercise, for each point, we're gonna draw a sphere center at a point, and then we're gonna output the sphere, right? So we have 100 points here. We're gonna draw 100 circles, all right? So we're gonna use okay, so we have a list input list I points here. We're gonna use a for loop to visit each point in the list of I points, right? The list I points. Okay, so this is what a program looks like. Okay. So first we want to remember the goal is to generate a sphere. So we have to declare a list, an empty list we call spheres. Okay. So first empty list spheres, empty list, and then for I in range from 0 to the number of points. So the number of elements in list, right? So this is gonna be I in the list going from 0 to 99. All right. Remember, length of I points gonna give us 100. Remember, and then range of 0 from 100 will give us, this whole thing will give us a list that go from 0 to 99. All right. So this is like this is a command which is like being used as an input to another command. So it can look confusing, but when the codes run, this command will be executed first, give you a number, and this number will be used as an input to this range. Okay, so Python allows you to nest or chain a lot of commands together as long as it makes sense. All right. Okay, so for I will run from 0 to 99. And each time it runs, I will use I to read out the points. Okay, so if I have a list of points, and then I will use a square bracket. This is I retrieve the element at the index I or the position I. That's gonna be my center of the current point of the current sphere that I want to draw. Okay, from the center, I can draw the sphere. Okay, so the sphere command take in a point 3D input. Okay, and the point 3D input is the center here, and then a float input, which is the value 0.5. I have a sphere, so this command will give me a sphere, and then I will add my sphere to the list of spheres so that I can output it at the final moment, the last minute. All right, so let's run this program. So I'm gonna copy this program into this component here. So you should see a bunch of sphere. The output, we haven't changed the name of the output to O sphere yet, so that's why we don't see anything else. So change the name of the output to O spheres. Run again. Okay, so all right, just let me repeat. In this example, we are given an existing list, and then we use a for loop to visit each element in the list. And each time, for each element, we generate a new element, which is sphere, and then we populate it into yet another list. Okay. Alright, so in the next step, you don't have to follow yet, just watch. Okay, if you think about this piece of code, I can simplify this code quite a bit because look at the counter I here. I is just a number going from 0 to 99, and the purpose why I need I is that so I can I can use it to retrieve the point, right? Because the point is organized in the index from 0 to 99. That's why I kind of need to generate this I from the list of number from 0 to 99. But remember, the end of the day is you interested in the actual point, not the index itself, right? So what about this? Remember, a for loop works for a list, okay? So what I can do, again, don't follow, just watch. What if I say for I in list of I points? In this case, the first time it runs, I will be the first point. Okay, it's not a number anymore. It will be the first point in the list because I point is a list of point, right? In that case, I will already be the point that I want, which basically the center there gonna be I. Okay. If I run this code, I get the same result. Okay. So all of the examples that we've done so far give you the impression that whenever you use a for loop, you always have to iterate it over a list of numbers, but you don't have to. You can iterate it to a list of points or objects. Okay. In this case, we should give it a more, this variable here, we should give it a more meaningful name. So I usually refer to an integer, but here clearly I is not an integer. It's actually a point, right? So and the point here is actually a center. So I should say for each point in points, or maybe for each center in I points, then okay, we should replace it with center. Okay, this is a more meaningful name. All right. All right, you don't have to try that. The sample code is in the next slide actually, so you don't have to try this one. However, there is a small advantage or a small difference. So this way of using the for loop only makes sense if you don't care about the value of the index. So for example, here when I draw the sphere around the center, I don't really care if the center is the 5th center in the list. I don't really care about its index number, right? Because the program doesn't really need to know the information. But there are certain cases where you need to know the index number because the logic depends on, for example, if you want to draw square at the number where the odd number and you want to draw a sphere at the even number, in that case, clearly you need to know the index number, right? So let me show you another example where you want to know the index number. So let me revert this to the previous logic. Okay, Control Z. Okay, so this is the same logic as before. No, a few more Control Z. Hang on. Damn it. Okay, just copy and paste. All right. In this case, if I know the number on the index I can use I to do something a little bit more creative. So rather than using a fixed radius 0.5, I can make it something that is changed according to I. So this code is R, which is radius, right? And R is, okay, so far R is 0.5, right? But rather than use a fixed value 0.5, why don't I make this something that changes according to I? Okay, so I'm gonna write a seemingly fancy formula. I will explain this in a moment. Okay, now you don't have to understand where I got this formula from, but the key takeaway message is that there is a letter I here, which means that whenever I change, the value of R will change, right? And of course I will change because the for loop I will change. So this kind of logic depends on the value of I. So you want to be able to achieve this effect if you use the other version of the for loop, the one I show you where you have for center in I point. This one will not tell you the index of the center. So you won't be able to use that index I to do this kind of creative logic here. Okay, so basically this one, when I change the radius change, so you will see the radius of the sphere being changed right here. Math cos I, this one should be what error I get here. Oh, there's no import math. Really, which line is it? Okay. Hang on. I run this thing again. Strange. this one is on slide number 21. So if you copy and paste to see if it runs in your computer. I don't see the problem with this sphere. Oh, this one is happy. Oh, it looks like my math library is not working at all. Did you get something? You get something? Okay, so somehow the math library on this component is not working properly. Okay, but at least I...
The negative values of the error.
Huh?
Maybe because of the negative.
No, this is a different error. If I get negative value, the error message will look different. It basically, the math library somehow is empty. But because yes. Okay, it doesn't matter. So 0.25, even that is not matter. Okay, what happened is that I will go from 0 to something, right? And as I increase, this whole value will basically oscillate. Huh?
This is the problem.
This one?
Yeah, you put it here and 9.
But even that should not cause a problem. It's just something, right? But even that should not give me this weird error. Now it seems to work. Really? So 9 is too big, but I don't see why I should complain about 9. Ooh. Oh yes, of course. Of course, yeah. You're right. It's negative if 9 is too big. I don't know where I got that 9 from. Maybe the slide is wrong. No. No idea. Okay, so okay, like I can explain why the formula give you this effect, but that is not really the important part. The important part is that I change yet and then R change. Okay, this whole thing will oscillate between -1 and 1, right? Because that's how the cosine function works. If you multiply something that oscillates between -1 and 1 with something, then this whole thing, I'm sorry, right here. So this whole thing will oscillate between minus 0.25 to plus 0.25, right? And if you add this thing to it, then the whole thing will oscillate between 0.5. So when this thing is minus 0.25, then the whole thing will be 0.5, right? And when this thing is maximum, which is 0.25, then it will be 1. So basically the value of R will be, as I change, the value of R will go from 0.5 to 1 and then dip down to 5 again according to the sine wave. Okay, the sine wave itself in math is just going from -1 to 1, but like we have to scale it. So this is just scale and offset, right? So that rather than going from -1 to 1, it go from 0.5 to 1. Okay, so the radius will basically go from 0.5 go up to 1, okay, and then go back to 0.5 again and go back to 1. So the radius is like a sine wave. A cos wave actually, okay. But anyway, the particular math is not it's not the main point here. It's just like some quick way to vary the value of I, to value the value of the radius, okay. Anyway, so now let's come to the next very common programming patterns that we're gonna use with the for loop and a list. Your assignment's gonna be depends a lot on these two parts, so pay attention. So two common list programming patterns. The first pattern. So what is pattern? Pattern, think of it as like a general technique or a template. When you do certain kind of tasks, like you end up like your code look very similar, the structure look very similar to each other, and that structure we call it a pattern, a programming pattern. Okay, but it's not as strict as a template, so that's why we call it patterns. All right, so we kind of done the patterns where we have an empty list and then we're gonna use a for loop to one by one add element to the end of that list, right? So this pattern is quite common whenever you want to generate geometry. Okay, so that's what the word pattern means. All right, now this pattern summation or accumulations. Okay, so let's say that we have a list of numbers and we want to add all of these numbers together. Now, of course, you don't want to retrieve each number manually and then add them up, right? We don't want to say numbers bracket 0 plus numbers bracket 1, right? You want to like do it automatically. Okay, and in this case, we just want to sum up the numbers. But let's say that what happened if that is not a list of number, but let's say a list of sphere, and then you want to add up the volume of the sphere. Okay, so you can use the same technique or pattern to achieve the same effect, and this is like very common later on when you do assignment or when you do projects. So for example, you have a list of let's say like 10 beams, and then you want to have to escalate the total length of the 10 beams so that you can work out the total material that you need for your robot, for example. Yeah, these routines or this pattern is very common. Okay, we can use a loop to compute to sum up all of the elements. Okay, and this is how it goes. So first, before we start a loop, we have a special variable. It's not really special. It's just a number, and we initialize to 0. Okay. That variable acts as the sum or an accumulator, okay, and you will see why it is known as an accumulator. Now we're gonna use a for loop to visit each number. Okay, so I will go from 0 to 7. I think so. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so I'm gonna use the for loop to retrieve the number. Okay, so this part is you already know, right? But what we do, so once we retrieve the element, we add it to sum. Okay, so this symbol here, plus equal to, basically just means, I can do it right here. Okay, so sum plus. Okay, so what does it mean? You take our number and you add it to the current value of sum, and then you get a new value, right? And then you override it with sum, so you start back. Okay, so look at the right hand side. Sum is 0. You add it with the first number, and you will get 2, right? And then you will start a number 2 in sum. Now the reason why you do that is that the next time the loop run, sum will now be 2. 2 will be added to 3, right? You get number 5. Okay, and number 5 will be stored back to sum again. So basically, you take a number, you add something to it. Okay. Now, of course, mathematically, this looks nonsense because the number cannot but equal to itself plus a positive. But remember, this equal is not comparing. It's not saying that sum equal to sum. This equal means assigning. I take a new value and I store it back in my container. Remember, the variable is just a container. So I update here. I retrieve the current value, modify it by adding number, and then whichever value I get, I store it back. Okay. And then if I keep doing that, so every time sum will grow, right? The sum will start with 0, but every time the loop run, I just accumulate or like add new numbers to it. So by the time the for loop finish, if I display sum, it will represent the addition of all the numbers. Okay, and this is a common programming technique called accumulation or summation, where you have an accumulator variable which is empty or 0 at first, and then you visit each element in the list, and then you accumulate it into the variable, okay, or sum it in the variable. All right. So that is the syntax, but that's a shorter syntax because this operations is so common in programming language, in programming. So many programming languages, including Python, allow you a shorthand notation, which basically plus equal to, okay, which is just a shorthand notation for the previous one. Okay. So again, this basically means take the number and add it to the variable here, to add to the existing value of the variable. Okay. All right. Equivalently, remember, so this is the version of the for loop where we're gonna use I to visit the index. Okay, we use I to retrieve each element using the index. But again, here we don't really care about the index. So the index doesn't play any role here apart from helping us to retrieve elements. So we can write the for loop in slightly different. So for number in numbers, okay, we just say sum at equal number. Okay, remember, number is just the name of the variable, and each time this for loop run, the variable will be equal to each element in the list. All right. So in this case, we don't really use the index anymore because the logic of summing something up doesn't really require us to know the index. Yeah. Okay. Print sum. Okay. do we have another example? Okay, this is a good example that deal with geometry. So this example just deal with number. You don't see any geometry output, right? Okay. Okay, now we're gonna try this one live because we're gonna see input. So the input, gonna be the input gonna be a bunch of points 3D, and then we're gonna compute the centroid of this thing. Now the centroid is basically we just add the x, y, z coordinates up, right? Okay, we sum it up, okay, and then we divide by the number of points, and that's how we get the centroid. All right. Now this is also a very common, very popular kind of tool or routine to have. Like, I'm a bit surprised that like Rhino Grasshopper doesn't have a built-in component to compute the centroid of a set of points. You can do it with existing component, but like there's no single component that do this job directly. So it's a nice example to do in Python. Okay, so let's prepare this component. Python. Oops. Wrong. Python. We're gonna input's gonna be I points. The input type, the list, the access type is list. Don't forget that. And then the type in is gonna be point 3D. Okay, and what is the output? Oh, the output is just a single centroid. So the output's gonna be O centroid. All right. I'm gonna give it a few input points that I choose manually on the Rhino viewport. It's better to do this point manually here because after the script runnings, we're gonna change the point on a viewport, and you're gonna see the script rerun, and the central output is gonna be updated live. Okay, so again, I just want to remind you, make sure this is a list input, otherwise the code gonna give you an error or something like that. List input and type in is point 3D. Okay, again, naming convention input prefix with I, and also by naming convention, I didn't tell you this, but it's also a naming convention. So a variable that is a list always should be in plural form. Okay, so variable name should always be a noun, obviously, but list is a plural noun, okay, and function name usually contains a verb in its name, okay. All right, so I points output is centroid. It's only one point, so that's why it's not plural. It's just a single point. It's not a list. All right. So the code. Let me walk you through the code. Variables. So we're gonna sum up the x, y, z coordinate, but we don't have to do it using three numbers because you can do it using like you keep like three separate number, like the sum x, the sum of y, and the sum of z. But conveniently for us, the Rhino common libraries already support the addition operator for the point 3D data type directly, so you don't have to manually like write out first point dot x plus second point dot x. You just say like first point dot second point, and then all of the coordinate will be added for you, and you will get the sum points automatically. Okay, so this is how we so before we start the for loop, we create the sum variable, called centroid, right? And the centroid we initialize it to a point whose coordinate is 0, 0, 0. So at this point, it's really not a centroid yet. It's just a temporary variable that we're gonna store the sum, okay, on the accumulation of the XYZ value. Okay, then we're gonna have the for loop that visits each point in the input list. Okay, so for each point in the input in I points, okay, we're gonna take that point and we add it to the centroid. Okay, add equal to, as I explained previously, it's just equal to adding it to itself. Okay, and after the for loop finish, centroid, the XYZ coordinate of centroid will be the sum of the XYZ of all of the points in the list, in the input list, right? And now we want to do final step. We want to divide it by the number of points. So divide by itself. So again, you know what plus equal means. So divide equals a similar meaning. Divide by itself. So this operation. So the right hand side is a number, right? So when you have a point 3D and you divide itself by a number, it's basically just, you know, divide the XYZ coordinate by that number, and you will get a new point as an answer. Okay. So now centroid, so after you define number of points, you get the centroid, and then you just need to output it. Okay. So I'm going to copy and paste it here. And you should see. Okay, so the centroid is being output here, but it looks similar to the other guy. So I'm gonna draw a little sphere around the centroid so that I can distinguish it better. Right, and if you got your script working, you can try changing the input points interactively, and you're gonna see the centroid being updated live. Okay, so that is the end of the summation or accumulation pattern. Okay, and this is a general pattern, but you will see that it's like very commonly used whenever you want to add things up or finding the sum or the total value of a list of elements. And this element doesn't have to be like a number. Here you see this is a list upon 3D where we add up the XYZ, or it can be a list of volume where a list of like a solid object or prep, closed preps where you can query the volume and just add them up. Okay. The next pattern is also very commonly used. Is called finding the extreme element inside a list. Okay, and now what does I mean by extreme? So that it depends. So extreme can be the smallest number in the list, for example. So in this example, let's say we have a list like this, and we want to retrieve the smallest value, which is obviously here the answer is number 1, right? But of course we want to write a program that like automatically tell us that like 1 is the smallest number, or similarly you can find the largest number. Okay, so in this case we find the smallest number, but it doesn't have to be just smallest and largest. The word extreme can mean anything. It just means the most, right? So if you have a list of points and you have another reference point, you can write a script that finds among the input list which point is closest to the given reference point. That is also a case where you find the extreme value, because I'm finding the closest. Okay, so closest is an extreme case. Okay, but let's do with number first. So most of the programming example that I start on, most of the concepts I always use numbers or text first because it's easy to understand, and then the second example is going to be based on Rhino geometry. Okay, so let's deal with number first. Okay, so I know that many of you who use Grasshopper, when I give you a list of number, and you end up, and if you have to find the largest number or the smallest number in that list, what you normally do is you sort that list, and then you, after the list is short, you retrieve the first element or the last element, right? And the first element is going to be the smallest one. However, in programming, nobody would do that, because sorting a list just so that you retrieve the first or the last element is extremely computationally wasteful. Like, because sorting a list actually take a lot of computational power. Okay, there's a much easier way to do that. That mimic like how we human do that. Okay, so let's forget about the code. just look at the number. Like if I ask you to find the smallest number, what you do as a human is that you scan through from left to right, okay? And as you scan from left to right, you remember the smallest number that you have encountered so far, okay? So 2, okay, so the first time is 2 is like the smallest I've seen so far, and then I visit 3 is clearly not smallest, so I forget about number 3, but I still store number 2 in my head, okay? And then I visit number 2, okay, so 2 is still not the next king of the hill, is still like, okay, and then I go to number 1, okay, so now 1 is the next king of the hill, so 1, I remember 1 in my head, and I don't remember anything previously, okay? And then 6, okay, I don't have to remember 6 because it cannot beat 1, and then 9, and 8, and 2, and by the end, I say, okay, clearly 1 is the smallest because that's the only number I remember in my head, okay, that's how we humans do it, and in programming, it's the same logic, okay? So, find the smallest number. So we have a variable that stores that current smallest number that we have encountered so far. So smallest, I should have called it smallest so far, but okay, we just call it smallest. And then we initialize to the first element in the list, okay? So of course at this point, it's not really the smallest yet, it's just the smallest that we have encountered so far. Which means that even before we begin, this is the smallest. Okay, and then we're gonna use a for loop to visit its numbers in the list. And then if that number is even smaller than the smallest that we have seen so far, then we update the smallest to be that number. Okay, so the next time, okay, so this is the first time the for loop run. If the next time, if the new number is really smaller than the already updated smallest, then we keep updating it. Okay, that's how we do it in the brain. We keep only one number, and then we keep updating our brain to only remember the smallest number. Okay, and then after the for loop finish, we just display the smallest. And this thing is the cheapest way or the most computationally efficient way. We just scan the list from left to right. Sorting a list is like way more expensive than just scanning a list from left to right, as you know. So, all right, we're not going to try this slide, but we're going to try the next one. Finding a nearest point relative to a reference point. Okay, now your assignment is going to be quite similar to this one, so we're going to do this live. You're going to pay attention. Again, for those of you who have like programming before, this kind of child play for you, but I guess for 95% of you or 99% of you here, it's going to be quite a new learning experience. So again, we have a list of points, which let's say, let's prepare the component first before we work the code. So I'm gonna copy this component. Okay, so a bunch, I turn off this component so I don't see the point. It's confusing. Okay, so this is my input points, and then I have another reference point. So let me check if the name is consistent with what I have on the slides. I point and I reference. Okay, so I reference, which itself is a single item, so item access, and the type hint is 3D, is point 3D. And the output name is gonna be O nearest, output nearest. Alright, so let's input a single point for the reference. Okay, so the reference can be moved in real time, and as I move the reference point, I should see the output O nearest change. Okay, so for again O nearest, I will draw a little sphere around it, just so that I can distinguish from other points. Alright, now we can start writing the code. Okay, so please watch. So that is our input and output name. Okay, so Now the code, of course, we need import Rhino geometry on top, but I kind of cut out that part from the code. I'm not even sure we need. No, we do. So nearest equal to. Okay, so we visit each point and we remember the one that is closest to the reference that we have encountered so far. So I create a temporary variable called nearest, but this should be called nearest so far, but I just call it nearest, and then I initialize nearest to the first point in the list. Okay. So currently this one is the king of the hill, right? This one has this one is nearest to my reference. Okay, now I'm gonna visit the remaining point and check if I have like the new king of the hill. So I'm gonna do some distance comparison. So if the current point dot distance to the reference point is less than the distance between that reference to my currently nearest point, then of course I have a new winner, right? In that case, I update nearest to the point. Okay, so similar to the logic of finding the smallest number. Okay, but this time the comparison criteria involve the distance rather than direct comparison. All right, and then I just output the nearest point. Yeah, very short. Okay, if I run this, right, you should see the nearest point here, which is the sphere. And as you change, if you move the reference point around, you should see the result being updated live. Okay, the next example is not on the slides, but I can do it here. It's just a modification of what we have so far. Now, in this case, we only interested in output the nearest point, but there are many cases where not just in addition to the actual nearest point, you also interested in the index of that particular point. So you somehow need to track that index as well. So here, the output is just a point 3D, right? But let's say that I also want to output the index of the nearest point, which is like, let's say the 5th point in the list. So this time, instead of remember the point, I will just remember the index of the nearest point. So this is how I modify it. Again, just watch. So nearest index, which is 0. So I assume that the point at index 0 is going to be my nearest. Okay, and then I'm going to visit its index. So for I in range between 0 and the length of I points. Okay, so you know this routine by now. And okay, now I have to retrieve the point first because this time I use the index for loop, not the point. So now I have to point equal to I points, retrieve I. Okay. All right, and then if this point is closer to my nearest point, which is this one, so point dot distance to reference is less than the distance between I reference and points at the nearest index. Okay, the nearest index, remember, tell me the nearest point I've encountered so far, so that's why I have to retrieve it to do the index, the distance math. Okay, so if this condition is satisfied, which means I have a new winner, so I have to update nearest index. So nearest index gonna be I. Okay, so this time we don't track the point, we track the index instead. Okay, and then after this thing finished, if we print out I, or we output I, then I will be the index of the nearest point. Okay, and sorry, it's not I, it's nearest index. Okay, so after this for loop, so nearest index is 0 at beginning, but after the for loop finish, nearest index will actually store the index of the actual point. And with the nearest index, so this is just a number, but like if you know the nearest index, then you can also get the point, right? So that is just the index, but for the actual nearest point, then you have to go to I points, and again give it nearest index to retrieve the actual point. Okay, so doing this way, you have both the point and the index of that point. I will save this one online because I don't have it on the token, unexpected token. Live free. Okay, missing a color. Live 5, if points. There should be I points, the input points, not points. I points. Okay, so the index of the nearest point is number 13, okay? In my case. Alright, I should save this on the Google Drive because it does... Okay. All right, so let's carry on. So we done list and loop. Now the next step is, okay, is everything okay? I mean, does your brain need a massage? Your brain needs some sort of massage or relaxation before we go on? Okay. Okay, nested loop. Okay, so we up one level now. So this is things get interesting, but also confusing at first. I will be very slow. So a nested loop is a for loop within a for loop. Okay, that sounds crazy. If you have never seen this before, so it's certainly confusing at first. Okay, that is the for loop that runs for 3 times, 0, 1, and 2. Okay. Now remember, inside the body of the for loop, I can have like a program that is as complex and as fanciful as I want. In fact, I can have an entire for loop run inside this for loop, which means that for each iterations of I have like a for loop that executes, let's say, 3 times. Okay, so let's say. Okay, so in this simple program, I just print out this message here, I equal to, this is the text, and then the value of I, okay? So if I run this, I will get 3 output, I equal to 1, I equal to 2, and I equal to 3, okay? So that's part is simple and easy to understand. Now, within the body of the for loop, we have another for loop. So see the indentations. Okay, so this for loop, J going from 0 to 3. Okay, and each time the J loop runs, I print out a message J equal to big J. Also, when I print out a message, I make an indentation here, just so that when things are being displayed in the output panel, the J is indented relatively to the I. Okay. Now, if I run this, what you see is first I equal to 0, okay, and then this loop kick in and J equal to 0, J equal to 1, J equal to 2, okay. All right, and now the loop going back to I again, and I will be 1, okay. So that's why we have I being 1 being printed out, and then J will do the same stuff, okay. You see the correlation between the code and the output. Now, when you run this code in the computer, you press the play button and you see everything appear immediately, as if everything is done like simultaneously. But remember, there's always a sequence, right? This line run first, and then J equal to 0, and then J equal to 2, 3, and then everything will come back again, and then you get this line. So everything happened in a sequence, okay? So that is what a nested for loop is. Of course, you can nest it like in as many level deep as you want, but here we stop at 2. So think about it. This is almost like you create a two-dimensional grid, right? It's just like I put it 0. This is like the way we lay it out here is like make it look linear and flat, but actually it's almost like a table, a two-dimensional table with I is the column and J is the row, right? So this is for row 0 you have 3 column, and for the row 1 you also have 3 columns. So even though we display the result in a linear, this logic capture or describe the logic of a two-dimensional table or the 2D grids very well. And you're going to see that we're going to use logic to generate a grid of points in 2D, in two-dimensional grids. So creating into this grid of points, so this one is live example. So let's create a Python component with one single output. Geometry. Okay, we don't have any input, so just output. All right, we're gonna import. Okay, so the import is familiar now. All right, we're gonna generate a list of points, right? So of course, you know this routine. We start with an empty list, and then we're gonna use a for loop to populate the content of the list. Okay, so we have a for loop I going from 0 to 50, similar to previously, but now inside this I loop, so for every value of I, we run J for 50 times, okay? And then ij gonna be our xy coordinate for the points, all right? And then we just output the points, all right? So I hope this is clear. Okay, so a quick question or quick exercise for those of you who have never seen nested for loops before. So according to this logic, so when we generate the points, right, of course everything appears simultaneously, but of course behind the scene everything is populated in order, right? So the question is, according to this code logic here, the points will appear in the x dimension first before going to the next column, or it will go this way. First row, second row, third row. Okay, so again, the question is, according to this logic, the row will appear in X row, and then the next X row, and the next X row, or it will appear in the Y manner, or like the first Y row, and then the second Y row, and the third Y row. Which way is it? Yes, the Y row first, okay? So if I reduce it to 1, so I only run once, I will got the first row, okay? All right. So this is like everything does have an order or a sequence of execution, as you see. Okay, so that part is easy. Okay, let's make this a bit more interesting. So far we have been using I and J as the as xy coordinate, right? And Z we put as 0, but this time let's make Z depends on I and J. Okay, so I and J going to change. Each part has a unique value for I and J, right? And if we do that to compute the Z, then Z gonna be different from each part as well. This is just a wave formula. Again, I'm not going into details why this will give us a wavy effect. But if you update your code with this extra, so replace the 0. So previously we have 0 here, right? Replace it with Z, and Z is this line here. Okay, then you're gonna see Z varies according to the sine wave formula. Okay, so one thing I missed in there was one slide missing before when we do that helix. We're missing the slide where we generate the curve that's going through all of those points actually, but it doesn't matter because we're going to do that like very same thing here. All right, so now instead of outputting the point, we're gonna collect each row of points in a list, and we're gonna put a line or a curve through those list of points. Okay, I should do it into separate steps. So just to demonstrate. Okay. You don't have to follow this step. So if I have a bunch of points in 3D space, this is how you generate an interpolate curve through a set of points using Python. So if I have that a bunch of points, okay, I input it to my Python script called iPoints. Again, you don't have to follow this step yet. Type in point 3D. Okay, the output's gonna be a curve. So we need import rhino.geometry.rg. If you have a list of points, which is so iPoint is my list of points, that's clear. To generate the curve, you're gonna say RG. Okay, so the library, and then NURBS curve. NURBS curve is the data type. Okay, so we have like the point 3D data type, the live 3D data type. Now here's the new geometry data type defined within the Rhino common library called NURBS curve. Okay, the NURBS curve data type has a special command. Well, I call it special, but it's nothing special. It's just like any other command defined within the data type. It's called create interpolate curve. Again, it's in the documentation, but here I kind of remember by heart how it works. So this function take in actually when you open a bracket, you see that there's like a mini documentation showing behind. So the create interpolate curve, it take in the first input is called point. It's just the name of the input, but the type of the input is the list of point 3D. So I give it iPoint. So iPoint is a list of point 3D, so it's clearly satisfied this one. Now IEnumerable is just a fancy name for a list. Okay, IEnumerable is a C# abstract data type that represent many things, including a list. So whenever you see the word IEnumerable in the documentation, when you see a command ask for an IEnumerable of point 3D, it means that you can give it a Python list of point 3D. Okay, such as this one. All right, comma. All right, so after the comma, the next input parameter, the name is degree, but again, the name is not important. The name is just like for human to understand, but the data type is an integer. So this is the degree of the curve. So degree of a curve, give it 3. Of course, what is the meaning of degree of the curve is another story. We're not going to describe it here, but like to get a smooth curve, you need at least degree 2, but normally we go for degree 3 to get a nice smooth curve. Okay, and then the next data type, and that's it really. So this command create interpolate curve, there are 3 versions. The first version take in 1, 2, 3, 4, 5 inputs, but we are using the last version here. This last version take in only 2 inputs, the list of points and the integer that describe the degree. Okay, so we use this short version because that's all we need. So this whole thing will give us a single curve which we can output. Okay, curve. All right, and as we okay, so as we change the input here, the curve will be updated. So the curve is like a smooth curve that's guaranteed to pass through all of the input control points. All right, that's how you do it, a single curve. But we're gonna do it for our waves just to show you some like list manipulation logic. Okay. All right. So remember, this is what we have. This is one to achieve. In this case, we don't even output the points. We just output the curve, right? So you don't see those square dots in this case anymore. So we still need to create a point inside the Python script, but we don't output it. So the point still live inside the Python program. It still live in the memory of the computer. It's just not being output in a Grasshopper canvas, and hence it is not being visible in the Rhino 3D viewport. Okay. So this is the logic. Let me walk you through. Okay. After we have the curve, we can create a rough surface, but we're going to save that for the next seminar because surface is like a topic on itself. Okay, so we're going to output a list of curves, right? So of course we need to first create an empty list of curves, just similarly. Okay, and now we're going to fill in that list of curves. Okay, so for I from 0 to 50, now remember, every time I runs, we get one row of points, right? All right, so each time it runs, we prepare an empty list of points, okay? And we're gonna use the for loop to populate in this row. Okay. Okay. This math is identical, so the coordinate of the points is identical. But this time, we save it in the points. Okay. We save it in the points list. But the point list, rather than store every single points in the 2D grid, it store only the points in one particular row, okay? Because every time I run, this list is being reset to empty, okay? So it's only store the current row of points. All right. So after the J loop finish, then points will store the entire row, right? So I can use points to construct the curve that I want, okay? So you see, this function is outside of the J loop, but still inside the I loop, okay? That's important to notice. And finally, we just append curve to this list curves here. All right. So points is outside of the J loop because points like being reset every time I runs, but curve is outside even of the I loop. All right. And finally, we just output. Okay. You see the relationship between the curves and the point here. So point is just a local like a temporary variable to store the points in one particular row. But the next time when we have a new value of I, we like reset the points to empty and populate with the point from a new row. Okay. So this curve here is basically only passing through the particular row of points, right? So if I copy this in. Okay, so the output is just curve now. I don't see the points anymore. All right. All right, just to check if you understand the logic. What if I accidentally forget to indent? Okay, what happened if I remove the indentations? In this case, I will only get the last curve, because if I undent it, then this thing will only execute after the for loop finished. Okay, so and when the for loop finished, this thing will only store the points of the last row. Okay, so I only get the last curve in the last row only, which is the 50 row here. Okay. All right. So, okay, this probably will take some time to absorb. But anyway, that's the end. Now let's talk about the assignment for next week. So assignment should be also on Google Drive already. Okay, you have 3 tasks here with clear solution. So this is a sample code as a starter. So this code will show you how to compute the angle between 2 vectors. Okay, it's very simple. the angle will be in radians, not degree. But I don't think it's a matter for next part of the code. So even if you mistakenly think of it as degree, it's still fine. These are the vectors. So the vector 100. So the data type is obviously vector 3D here. Okay, it actually shows on my lower screen, so you don't see that pop-up window here, but it says vector 3D. Okay, so if you have two vector, you can compute the angle between them using this function here. Okay. All right. So now I'm asking you to the first task is compute the angle between two lines. Okay. So from the lines, lines in Rhino has direction. So lines in Rhino has a starting point and an ending point. So they do have a positive direction, right? So I want to you to compute similar to the code I show you here. Now the input is two lines. I want you to compute the angles between those two lines according to their positive directions. Okay. So there's nothing in the code, just the import Rhino geometry. This is easy. It can be done in maximum two lines. One line for sure, but like maximum 2 or 3 lines. All right. Once you know how to compute the angles between a pair of lines, then now we're going to do the for loop logic. So here I have a bunch of input lines. All right. This is my input lines. And this is a reference line. So the reference line is also being controlled by 2 points here. Now I want you to figure out which among these lines has the most similar angle or orientations to the input one. Okay, so basically you just compute the angle between the reference line to each of these one and see which one is closest to 0. If they are fully aligned, then they are 0, right? Okay, but not all of them 0. So the most aligned, the most similar orientation means the one that like has the angle this is smallest, okay, or closest to 0. This is a classic case of finding the most extreme elements, as you already done before. Okay, so all right, and then the task number 3 also involve a for loop. This one is also easy, but this one is this task 3 is independent from all the tasks. So input is a bunch of points and a circle. Okay, so the data type here is a circle. So this one is circle again, but you don't see it because it's on my smaller screen. But you will need to look up the documentation of the data type circle to see what a property a circle have. So here inside, if I say I circle, okay, obviously, autocomplete, because I set it as circle, then autocomplete recognizes it's a circle. That's why I can say I circle dot radius or center point. Okay, all right. So your goal is to output the result output here should be all of the points that lie within the circle. Okay, so you're gonna do some distance comparison and compare it with. Okay, and then the output is gonna be a list, obviously. Okay, so you have an input list, and then you have to filter out the relevant element in that list, and you get a smaller list and output that list. Okay, all right. So this is about list and loop essentially assignment. Okay, so please remember to submit it by the next seminar. Okay.
How do you want us to display the result for task 2? Like it would just...
The result is going to be just a single line, right? So you output a single line, and if you highlight on it, you're going to see a single green line being displayed. In order to distinguish, you can probably convert it to a cylinder so you can distinguish. But it doesn't matter. As long as I can see something, when I check your assignment, if I see something coming out here, I can read it and then I can verify if it's correct. That should be enough. Okay, but for your own sake, when you're debugging, having a visual output is easier for you to debug. Okay. All right. All right. See you next week then.